1 on section 9.1. And the examples 2 and 3 you should have tried on your own. You can check them against the website, or you should have checked them against the website. So I'd like you to recall a few things. First of all, we talked about hypotheses, and we talked about the null and the alternative hypotheses. First, I'd like you to remember that hypotheses are always about parameters, not about sample statistics. The second thing I'd like you to recall is the null hypothesis, or H0, is like the status quo. In other words, what normally is, or what we have assumed to be the case, or we're told to be the case. So, for example, I might say that mu, the mean, is 30. The alternative hypothesis is HA. And so we have two versions of the alternative hypothesis. One is a one-sided alternative hypothesis, where our parameter is either greater than the HO value, or the parameter is less than the HO value. One or the other. So, in other words, one of, in our example, one of mu being greater than 30 or mu being less than 30 in our example. If you have a one-sided alternative hypothesis, you will be using a one-tailed or one-sided significance test. In other words, you're only interested in the side of your sampling distribution that matches your one-sided alternative hypothesis. A two-sided alternative hypothesis is when the parameter is different from the value. So from the H0 value, the null hypothesis value. So for example, mu is not equal to 30. In other words, mu is going to be less than 30, or it's going to be greater than 30. In other words, it could be in either place. So in this case, we would use a two-tailed or two-sided significance test. So we'd look at both sides of the distribution. In order to get to decide, make our decision on our test. Okay. So now we're going to define p-value, and it's the probability computed assuming that HO not is true, that the statistic, such as p hat or x bar, would take a value as extreme or more extreme than the one actually observed, and that's what we call the p-value of the test. Okay. So, for example, if H0 is that mu equals 0.08, and HA is that mu is less than 0.08. Sorry, I meant to say 0.8 for each of these. So mu is, H naught is mu is equal to 0.8, and HA is mu is less than 0.8. And if we get x bar equal to 0.64. Now, this is telling us we're looking at a one-sided test, and so our p-value is the probability that we would get a sample mean less than or equal to 0.64, given that our mean is 0.8. So that's how we would word it. If our p-value is small, in other words, we have a lower probability that such a value would occur if H naught is true. Okay. So a small p-value means we have a lower probability that we would get that if H naught is true. In that case, we have evidence against H naught, and therefore we can reject H naught. If our p-value is large, in other words, we have a greater probability that such a value, or a statistic, would occur if H naught is true, then this is not convincing evidence against not convincing evidence against H naught, therefore we fail to reject H naught. Now I'd like you to be very careful of our wording. We never accept H naught. We only reject it or fail to reject it. So we don't accept it if we have large p-values. All right, for example number 4, we're looking at the job satisfaction study continued. So the data in the study described in example 1, which we'll zip back up to quickly. Here we go. Where we were looking at job satisfaction of assembly line workers, and we tested them by giving them machine-paced work and self-paced work and then flipping them so that they could compare the one against the other for each person. So looking back at that situation, we are looking at, we've been given that we have a p-value of 0.2302, and our data collected gave X bar as 17. In other words, that they rated the self-paced environment 17 points higher than the machine-paced environment. And we want to know, first of all, what does the p-value mean for this? Sorry, not what the p-value means, but what does it mean for the null hypothesis to be true in this setting? So I'd like you to have a quick glance at these and try them yourself, and then come back. So in this case, H naught mu equals 0. This is the mean difference in satisfaction scores for the entire population of workers is 0. Okay, so if it is true, then the workers don't favor one work environment over the other on average. One work environment over the other on average. Now, interpret the p-value in context. Once again, remember you need to be answering your questions in sentences. Here I might do some abbreviations. On a test, you should be writing full sentences, full words. So in this case, the probability of observing sample results as one or more as or more extreme in the direction specified by HA, the alternative hypothesis, just by chance, when the null hypothesis is actually true. So that's what the p-value means. And in this case, since HA is two-sided, we need to look at both tails. So an average difference of 17 or more points between the two environments would occur about 23% of the time, just by chance, in random samples of 18 assembly line workers when the true population mean equals 0. Okay. Now, last question is, do the data provide convincing evidence against the null hypothesis? So, we need to assess this p-value. So, an outcome that will occur as often as this and that's 23%, is almost 25%, so approximately 1 in 4. Just by chance, when H naught is true, is not convincing evidence against H naught. Therefore, we would not be able to reject H naught.